as well. All right, so let's get started. So the examiner at the beginning gave us two matrices, L and N. And they wanted us to find L minus N squared. Well, I have that written on the right-hand side of the screen there. So all we have to do at the beginning of the question, at least, is just replace the matrices with the values. So L is how much? 3, 1, 2, and what? 4. And they ask us to minus N squared. So let me change the color for N. How much is N? Minus 1, 3, 0, and 2. And the examiner says that we must have it squared. Now, I'm sure everyone has up to there at least. Now, just a quick review, just in case you didn't remember. If I have 5 squared, now everyone can work this out because in primary school, they taught us how to square stuff. So 5 squared is 25. We all know this. We all know 3 squared is 9. But how much is minus 5 squared? Whenever you square anything in the world, you get a positive value. You have to remember that. So minus 5 squared is still positive 25, not minus 25. All right, so that's a common mistake, right? And the same thing would go if you had minus 3 squared, you would get positive 9. If you had minus 1 squared, you would obviously get still positive 1. So I'm going to write something on the screen, and I want everyone to confirm. I want to know how much of you all have this at least. You have the 3, 1, the 2, and the 4, well, that is L, minus, and you have a squared here. Now, this squared refers to the brackets here. So that means most likely you have to square everyone inside the brackets. So minus 1 squared is 1. Remember, we said this. We're going to square everyone inside here. 3 squared is 9. 0 squared is still 0. And 2 squared is 4. How much people have up to here at least? How much people have that line written in their books at least? A lot of people are saying yes, yes, yes. Right? Remember, you're squaring everyone in the brackets. All right? Great. For everyone who just said they had it, this is wrong. 100% wrong. No, I did it on purpose. I did it on purpose, right? Yesterday, class made the same mistake. I made the same mistake when I was doing maths in school, and the majority of the students would make the same mistake. And the examiner here has intentionally put this trick in the question. So let's see what's so wrong about what we did. Remember, we just simply squared everyone in the brackets because there was a square. So why is it wrong? Well, let's go back to 5 squared. What does 5 squared mean? In primary school, your teacher would have said 5 squared means 5 multiplied by another what? 5. Isn't that what square means? You would multiply the item by itself. Great. So, you know what this really means? This means that if you have a squared here, we are supposed to take the matrix, the blue matrix, and actually multiply it by itself. Remember last term, I showed you how to multiply a 2 by 2 matrix by a next 2 by 2 matrix. That's the one where you split this down the middle. And it's 2 sums mixed into 1 sum. The 0 will swing up to the top. The 2 will swing up to the top. Okay? So guys, take it from there now. Okay? I would like you all to work out the blue part first. When you're squaring a matrix, it's not as simple as just squaring each number, right? Okay, so for everyone who got it wrong, you understand your mistakes so far, right? Just confirm with me that if you understand why you were wrong, okay? And to tell you the truth, I mean, if you go through your past papers, this is such a common trick, and the examiner knows for a fact that students fall for this trick. So it's kind of intentional, right? So I'm not going to work out this part for you because we spent a lot of time last term multiplying 2 by 2 matrices by our next 2 by 2 matrices. So I would just put my answer in a little while here. All right, so finish that blue part off for me at least, right? And some people told me that they didn't fall for the trick, which is great. Right, so Haley, you have an answer there already. So pause it here, because I know multiplying 2 by 2 matrices will take a while, right? And for those who are new to the class, don't worry. After class, I will show you where to find all the videos that will show you how to multiply matrices together and whatnot. But for the time being, just take the notes, right? All right, so the first two, I get 1 and 0. And for the next one, I'm getting positive 3 and 4, right? That's what I'm getting when I multiply the two blue pieces, the squared part. Great. A lot of people are saying, yes, that is what you're getting. I mean, if you get it wrong, not a problem, but just don't copy down my answer, obviously. Go back to your working and see where you could have made this small mistake. Right, and now we can complete part A because they want us to minus L and N squared. So we have L and this is the N squared. Well, minusing matrices is very easy. We just have to minus everyone in the same position. 3 minus 1, both of them in the same position is 2. 1 minus 0 is still 1. 2 minus 3 is minus 1, right? And then 4 minus 4 is 0. This white answer here is your final answer for part E. Right, so Gerard, Senika, right? I know I'm not responding to everyone, right? But I'm watching the answers. And if I see anything seriously wrong, I'll mention it, right? Right, Mohammed, check back and see where you could have gone wrong. All right, Mohammed? All right, so for those who got part A, move on. Let me do a little bit of revision before I do part B now, right? So don't try part B as yet. Let me give you some background theory behind it first. Refresh your memory. Okay, so let's take a 10 seconds, take down anything you need to take down. All right, so scrolling down now. I'll leave that at least. All right, so part B. So part B is talking about something called singular matrices. That is what they are talking about. Now, last term I had briefly mentioned what a singular matrix is. Let's go back to the theory of the determinant. This is my own made up example here. Let's say I have a 2 by 2 matrix and it's 5, 2, minus 1, and 3. And I ask you to say, hey, find the determinant of this matrix, right? To find the determinant of a matrix, you have to multiply this diagonal first, all right? So you have to say 5 by 2 is 10, And right after, you have to put a minus sign, no matter what. And then you multiply the other diagonal. 3 multiplied by minus 2 just so happens to give us minus 3. So according to this, two minus signs are touching. So you get a positive. So you end up with 10 plus 3, which is 13. You just have to always remember to put this minus sign after the first multiplication. This here is not a singular matrix. Let me explain why. Because in a singular matrix, the determinant is always equal to 0. So when we found the determinant of this matrix, we did not get 0. Hence, it's a regular matrix. It's not a special matrix. They call a singular matrix. So quick question. Is the green matrix here a singular matrix? The green matrix, is that a singular matrix? Yes or no? Work it out and find out. Vishala, you say yes, it is a singular matrix. All right, so let's do the working. Let's see if there's any tricks in this question. One person says no. All right, so to find the determinant, we have to multiply this matrix first. So half the class is saying yes and half the class is saying no. So 7 by 2 is 14. We must put a minus sign after. That's part of the formula. And then we multiply the other diagonal. Minus 14 multiplied by minus 1 is positive 14. But when a positive and a minus meet, you're going to get a minus anyway. So the answer is 0. So yes, this is a singular matrix. All right? So you have to realize that when you multiply 2 minus, you just get a positive. And when a positive and a minus touch, but you ultimately get what? A minus sign. All right? So, and one thing else you need to know, when you square root something in maths, you just get 2 answers. Remember, we mentioned that last term. The square root of 49 is not 7. It's 7 and minus 7 at the same time, positive and minus 7. It's just when you square root something, your calculator does only give you one answer, the positive answer. You have to know there's a second answer, which is negative. So that means the square root of 25 is actually positive 5 and minus 5 at the same point in time. You have more than enough information to do part B now, right? To do part B, and I think one person almost got part B correct. I think Gerald, you almost get part B correct. You just made a slight mistake. So try back one more time. Right, Haley, correct now. Right, Emily, correct. Gerard, you have to use the 12 and the 3 somehow in the question, right? Samara, almost correct. Mohammed, almost correct. Naomi, you have plenty more to do in the question. Jail, sir, correct. Ariana, correct. Darian, almost correct. Almost. Gerard, almost correct. Ariana, no. Hear me, Ayana, no. Zachary, no. Tiana, almost correct. I'll take one more answer. Adara, correct. Giovanna, paper one is a multiple choice. So you'll have to choose whichever answer they give you. Remember, paper one is a multiple choice. You can't write your own answer on it. All right, so let's see what slight mistakes people are making here. So in B, they said M was a singular matrix. They came out right and said M is a singular matrix. So that means if we were to find the determinant of M, we will get 0. So let's go ahead and find the determinant. We have to multiply this diagonal first. X by X is X squared. As soon as you finish this multiplication, you must put a minus sign. Then you multiply the other diagonal. 3 by 12 is 36. Now we can't really simplify this. But remember, this is the determinant, the expression representing the determinant. But they said, since it's a singular matrix, this is supposed to be equal to 0. And they're asking you to solve for x, and that's the whole point of the question. So how do we solve for x? We get x on one side and everyone else on the other side. So we take the minus 36, we throw him across. So you get x squared is equal to positive 36. But we're not finished. Remember, there's an annoying squared here. Throw across the squared and we get a square root. But remember, we now said, and too many people are getting this part wrong. We now said that when you square root something, you don't get one answer. So too many people are only sending one answer. The square root of 36 is positive 6 and minus 6. This is exactly how you're going to write it in the exam. All right, guys, so make a note, right? Somewhere on the, in your book that when you square root something, you're supposed to get two answers, a positive one and a minus one. If you forget the minus one, you're obviously going to lose some marks in the exam. All right, so take down your work in there, right? And let's scroll it down a little bit. All right. Part C, all right. Give part C a read and let me know if you are a little bit confused with part C, right? Part C is actually a very simple question. It's just that the wording makes you think that we did not do this topic, but we actually did the part C. They just worded it differently. So let me know if you need a jump start on part C, and I will gladly do a small review for you. A lot of the times, right? So this is an excuse to discuss something else. We know there are different sizes of matrices. For example, I'm just gonna color code it, right? This orange one, if I put 2, 4, minus 1, and 3, this is what you call the 2 by 2 matrix. Well, to keep it simple, the one with 4 numbers, right? And then in a lot of the cases, you have the one with the 2 numbers, like 5 and 1 here, right? We'll make it a little bit harder, put minus 1. So a big use of matrices is to apply it to a point to change the coordinates of the point. For example, let's say on a graph, we have a point A, and I tell you A is 2 minus 4. So I come and tell you A is the point 2 minus 4 on a piece of graph paper, all right? Let's just say, right? what we can do is take a matrix and apply it. Here's the word I'm using, apply it. We're going to apply the matrix to the point. Now, anytime you apply a matrix to a point, the coordinates of the point will most likely change. So we are going to apply the orange matrix to the point A. So let's do that. How would we normally do a question like this? Let's take the orange matrix, which is 2, -1, 4, and 3, and let's apply it. Now, you notice the orange matrix is the one with the 4 numbers. Whenever you are applying one with 4 numbers, you just multiply it. And the point A, when it's time to apply it or multiply it, you just write it vertical. Notice the X on top and the Y underneath. You think you all could apply the orange matrix to the point A and tell me what the new coordinates will be? How much would A dash be? Well, A prime. Let the -4 swing to the top and whatnot. Right? And this is my own made-up example, right? We'll go back to the question just now. But follow along with this question. It's something that is give a lot of problems in the exam. Right? So in case you can't remember how to do it, well, this one easy to explain. The -4 is going to swing up to the top. And then the 2 will go here, the -4 will go here, the 2 will go here, the -4 will go here. And you all know what to do. Multiply each pair, right? I don't want to confuse it too much. Right. Seen some wrong answers. Just so, huh? Why so many people getting this wrong? Oh, sorry. I tell you, you're wrong. And already supposed to put 2 -4 here. My mistake, guys. My mistake. I write the wrong thing and tell you, you're wrong. A is 2 -4. My mistake. So you get 2 by 2 is 4. So you get in -12 here and -14. All right. So the point A dash is now -12 -14. And remember, he is point what? A. Right. So let me use the technical terms here, right? So we apply in the matrix to point A, and A turns into a different point. But I don't want to use the term, it turns into a different point. The technical word for that is map. A gets mapped to a different point. That is all the word map means here. It means that the point was 2, 1, and because of the matrix, it changed into a different value. But that's not even the main point of what I'm trying to discuss here. Let's change up the question a little bit now. How about we apply the blue matrix to the point A? Right? So we're going to apply the blue matrix to the point A. All right, so how is this going to be different? The orange matrix has 4 numbers. The blue matrix only has 2 numbers. Whenever your matrix has 2 numbers, when it's time to apply it, you do not multiply it. To apply it, you just have to add it. And that's the difference. when you are applying a 2, the one with 4 numbers, it's a multiply. When it's 2 numbers, you just have to add it. So we have to add it to 2 minus 4, which is 8. And the adding one is the easy one. You just add the 2 top numbers and you add the 2 underneath numbers. You think you can send the answers over here? For A dash, this point will get mapped to what because of the blue matrix? Right, Cassidy, correct. Right, Tiana, correct. Selena, check it back. Jordan, correct. Gerard, check it back. Gerard, you multiply my mistake. Remember, we just simply added and subtracting matrices is the one you hope to get in the exam. That's an easy one. You just have to say 5 plus 2 is 7. Minus 1 plus minus 4. What a plus and a minus is a minus. You will get minus 5. Minus 1 minus 4. All right? So, and that is what I wanted to discuss. When you're applying a matrix, the one with 4 numbers, you just have to multiply it by the point. And the one with the 2 numbers, you just have to add it to the point. So I'm going to be asking you when we're doing the questions today, whether it's an addition type of question or whether it is a multiplication type of question. All right, so let's look at part C. I've seen some correct answers coming up for part C, but I've seen wrong answers coming up also. Part C. A geometric transformation, don't let the word geometric get to you. It's just a transformation, right? It maps the point 2, 1 to minus 1, 2. And the matrix C is what? R. So this is what they are trying to say. The matrix C R, right? Which is 0, P, Q, 0. They're trying to say if they apply it to the point 2, 1, you will get minus 1, 2. What kind of question is this? Multiplication or addition? It has to be a multiply, right? Because the matrix has how much items? 1, 2, 3, and 4. So we are going to apply it to which point? 2, 1, but I have to write it vertical. So when we apply it to this point, it changes or it gets mapped to a different set of values. That is what they are trying to say. So all we have to do is try to simplify this side, and I'm going to try my best to do that now. It's a multiplication. So how do you multiply? The 1 swings up to the top, the 2 and the 1 go here, and the 2 and the 1 go here. Multiply each pair here for me, and try your best to simplify it. Whenever you take a 4 matrix C, and multiplied by the one with 2 numbers, you just end up with 2 numbers. Right, I want to know what we're going to get on this side here. Also, anything multiplied by 0 is 0. Haley, I think you're on the right track there. Tiana, correct? Selena, correct. All right, let me see what's going on here. 2 by 0 is 0, 1 by P is P. So 0 plus P is P. 2 by Q is 2Q, 0 by 1 is 0. 2q plus 0 is 2q, right? Great. So all you notice now, we have 2 items on this side and 2 items on this side. So we're just going to make a comparison here. The top is equal to the top and the underneath is equal to the underneath. So that means P is equal to minus 1 and 2Q is equal to 2. And we have this one here, P is already the subject. So we solve for P here already. And now we have to solve for Q here. Well, we can do this in our head, right? Throw across the multiply, you get a divide. So Q is 1. P is minus 1 and Q is positive 1. That's your final answer for part C. All right, so try D now. Quick question. As soon as you reach D, is it an addition type of question or a multiplication type of question? Right, and everyone is answering correct. It's obviously going to be an addition type of question. Right, so you should be able to handle that one. I'm trying to get some. So T is R S, right? I have to write my S properly because if you write your S bad, it looks like a 5, right? It maps the point 5, 3. So that means we take in RS and applying it. So it's an addition to 5, 3. And when we do that, we get 1, 1. Well, adding matrices are very easy. R plus 5 is just R plus 5. I know some of you all multiply by mistake, even though we said it's an addition because this is a 2-digit matrix. And we have to add the 2 underneath now. S plus 3 is just S plus 3. Now we can't simplify this because we can't add R and 5. So at the end of the day, this is one number here. It's just we can't simplify it to the one number. And this is also one number. So that means R plus 5 is equal to 1. And the underneath, S plus 3 just so happens to also be equal to 1. Pure coincidence. For those who got it wrong, you think you could solve for R now? You just throw across the positive 5. And you think you could solve for S now? You just throw across the positive 3. All right? So solve for R and S and send your final answers, please. Right, Selena, correct now. Yeah, no problem, Rian. Kimaya, just now. Kimaya, check your signs, check your signs. Cassidy, correct. Christian, correct, right? So now you're throwing across positive 5 to get minus 5, positive 3 to get minus 3. It is minor mistakes here with the signs. 1 minus 5 is minus 4. 1 minus 3 is minus 2. Don't worry, Jordan. You'll get through for the next one. Right. When you're finished, try E. E actually is pretty easy, right? Um, that's for R, P, I'm just trying to remember. Remember we had when we had done C. I don't want to scroll up. P was 1 and Q was -1, or was it the other way around? Was the Q the positive one, or was the P the positive one? The P was the -1. Oh, okay, okay, okay. Well, it's a good thing you're telling us. Right, good. All right. Right, so remember we know the values of P and Q, and we know the values of R and S, right? So at the end of the day, R was how much? 0, -1, 1, 0, and we know how much is T. T is -4 and -2. So here's what I want you to do with this question. You have this point. They want you to do two things, one after the other, not at the same time. They want you to apply R, and when you get that new answer, they want you to apply T afterwards to the new answer. Right? I'm gonna scroll down here a little bit. R is the one with 4 items in it. So multiply it by the 0.85. And let's see what we get here first of all. All right, so for the first part of the question, when I apply R, I'm getting -5 and 8. I don't I change the orientation of the coordinates. Yeah, yeah, Abdullah, but when it's time to multiply the coordinates or apply it, you have to write it vertical. The 8 has to go on top and the 5 has to go underneath. You have to do that. You understand, Abdullah? Remember, all right, cool. If you leave it horizontal, I guarantee you that would be an impossible question to do in maths. Right, so keep your eyes now on the green coordinates. That's the new answer. They said followed by T. So you're taking the green coordinates, which is -5, 8 now, and you're applying which matrix now? T. And T is how much? -4, -2. You could have put it first. So you could have the -4, -2 first, right? Well, when you're adding or subtracting matrices, it doesn't matter which one you put first or which one you put second. You want to send your final answers? Let me see what you get here. All right, so Haley, I think you're correct. Samara, Zachary, correct. Right, Shaniqua, Stefan, right? -5 -4 is -9, and 8 -2 is 6. This is your final answer for part E. All right, so we just finished question 14, and that's 15 marks. Now, to be fair, right, and this is our old past paper. Remember, this is 10 years ago. The questions usually don't come this hard anymore, right? Or so long. I should say it doesn't come so long with 5 parts in it. In most exams, you won't get A to E. You'll just get from A to B, or you'll get C and D only. All right. But it's good to practice with these long, hard questions because they will build your confidence and just get you better at maths in any case. All right. So if you understood everything that went on, even if you got it wrong, once you understood what went on eventually, you should feel good about yourself. All right. All right, so let's move on, right? You're not gonna like the next question. So remember, we're working backwards, right? Question 13 is vectors. I need for everyone to draw this diagram. Don't draw it too small, right? Draw it a little sizable in your books, right? Take about a 20 seconds and we'll get started on the question, right? So let me start drawing it in the meantime. E. All right. And a lot of people are saying it. It's called a position vector because position vectors are connected to the origin. Now, position vectors, you should be happy when you see them. Position vectors are the easiest type of vectors to deal with. Whenever a point is connected to the origin, to convert it to a vector, the point itself becomes the vector. The -1 just goes on top, the x coordinate and the y coordinate goes underneath. As simple as that. So here will be 5, 0. So OB is -1 and 4, and OA is 5, what? 0. So I think I just gave away the answer for part A. OB is what? -1, 4. That is all they wanted you to do. Put the x coordinate on top and the y coordinate underneath. That is all. And part B is equally as easy. They just want you to take OA and add it to OB. OA is how much? 5, 0. I have it on the screen here. And OB, well, we have it here. -1, 4. You want to simplify this for me and send your final answers? Add the 2 top numbers, add the 2 underneath numbers. All right, Haley, correct. All right, Zachary, correct. I remember vectors is all about direction. When you go against the arrow, you have to make the sign the opposite. But we didn't encounter any of that at the moment. Right, so everyone is getting the correct. 4, 4. 5 plus -1 is 4. 0 plus 4 is 4. Right, I think this has to be the easiest thing we do for the entire night so far. All right, the easiest thing so far. All right, before you do part 2, let me just give you a little revision on part 2. Part 2 actually has nothing to do with vectors. Nothing to do, even though it's in the vectors section. Lines and midpoints. If you have a line, like any line in the world, right? Let's say the beginning of the line is P and it's 7 minus 3. And the end of the line is Q. And let it be minus 10 minus 8. And just say, all lines must have a midpoint. It must have a middle. And the middle must have an x coordinate, and it also must have what? A y coordinate. So usually in most textbooks, right, to denote the midpoint, you just call it xm and ym. X middle, y middle. That's what the m stands for. To calculate the x coordinate of the middle, all you have to do is take the 2x coordinates, add it, and divide it by 2. We did this in August, sometime around there. So P and Q. P is the beginning of the line, Q is the ending of the line. P has an x coordinate and it has a y coordinate. So call it x1 and y1. Q is what? The end of the line. So call it x2 and y2. To calculate the x middle point, we just take x1 and add it to x2, and whatever you get, divided by 2. But do me a favor. When you're using the formula, put the top in brackets. Otherwise, some calculators will give you a wrong answer. To get the y coordinate, you add y1 and y2, and you divide it by 2. That's just the formula. You always divide by 2. But you have to make sure and put it in brackets, right? Yeah, we did this last term as well, right? But just refreshing everyone's memory, right? You think for my made up example, you can calculate the x middle coordinate and the y middle coordinate. Please remember the brackets. I know some of you are thinking, well, that's not too important. It's real important, right? So calculate x and xm, sorry, and ym. Send your answers across. Kiara. Cassidy, just now, you have that right, Cassidy. Kiara, you sure that's correct? Kiara, okay, just to kind of backtrack, right? Guys, remember we now spoke about these brackets and how it's super important. At least they just put a note somewhere now stating that, hey, those brackets real important because too many people making the mistake, they're leaving out the brackets, even though I said it so many times. All right, so for those, Kiara, you're one of them, right? You want to try it back, please? And too many people are, Adrian, you are not putting your brackets. Rian, you are not putting your brackets. All right, so let's see what's going on here. You have in brackets 7 plus minus 10, because you have to add, but the next number is a minus. Well, we know a plus and a minus is a minus, right? So if I put the brackets here, I know for sure I'm going to get minus 1.5 on my calculator. I have no way, and too many people are forgetting the minus sign here, right? And we're going to do the same thing for the y middle. Minus 3 plus minus 8, and then we divide it by 2. Well, a plus and a minus is a minus. So you're already typing in minus 3 minus 8 in brackets, and you divide it by 2. And we will definitely get minus 5.5. Right? Minus, sorry, 5.5. So the x coordinates over here, you have to write it like this now. Minus 1.5, comma, minus 5.5, close brackets. Or you can leave it in, I've seen some people leaving it in fraction form. That is fine also. Right? If you have minus 3 on 2 and minus 11 on 2, it's just as correct. All right, so for the persons who got it wrong and you forgot the brackets, make a note. So in the exam, you don't forget. Let's do it here. 7 minus 10, close brackets, divided by 2. And you get minus 1.5. And the other one is the same. I just proven it, well, I'm looking for a space here. And the other one is open brackets, minus 3, minus 8, close brackets. So I put in my brackets divided by 2. I just confirming it. You see, I got minus 5.5. So I know I'm correct for sure. Right? So I didn't make any errors for those who have the little doubts. All right. So with you think you can handle part 2 for me now? They want you to find the midpoint of AB. You have point A and you have point B. Call A x1 and y1 and call B x2 and y2. Just like how I did it here. Vishada, check it back. Right? It doesn't matter which point you choose first. If you choose A first, you call it x1 and y1. And the point B will be what? X2 and y2. So you can calculate xm and ym. Right, so a lot of correct answers are coming up now. Five plus minus 1, and the other one is 0 plus 4. Plus and a minus, you'll get 2 and a next 2. So the midpoint would be 2, 2. Right, work until they get it there, and don't forget the brackets. For those who are finished, please give part B a read and then draw this diagram. Draw a huge diagram in your book, right? Make it take about 1/3 of a page or something like that. Part B is going to take us about 30 minutes to do. It's a ridiculously long question. All right, so let me pause it here and give you some time to draw the diagram and whatnot. Okay. You just have to recall a few rules when it comes to vectors, right? A few basic rules. Remember that when you have a vector, direction matters. For example, if I have a vector this way, and I tell you the value of the vector in the direction of the arrow from O to A, let's just call it O to A, is 6p. So OA would be positive 6p. If we go against the arrow, like we go from A to O, what would be the value of the vector? We have to remember to change the, right? People are sending the correct answer. If you're supposed to change the sign, when you're going against the arrow, it will become minus 6p. Remember, well, you can't forget only the letter P, right? That was a key thing in vectors. Also, if I have the vector, in this case here, you're seeing the letter U and the letter V. If I tell you this way is positive V, then if we go the opposite way, it's minus V, obviously. Because this V is really one V and it's positive. It's just sorry that the examiner never bothered to put in the number 1 and he never bothered to put the positive sign. Those things are understood. So if we go the opposite way, it will be minus 1v. The same thing for u. If this way is positive 1u, then the opposite way is minus u or minus 1u. It's just that the letters and the numbers are so simple. The student not expecting something so simple. So you know what has happened in a situation like that? You just end up doing madness and you get it wrong. Okay. All right. Part A, HF. You think you all could do that one for me? How much is HF? Well, most likely you're going to get confused with this question, right? But just take a try, and well, if you get it wrong, you get it wrong. If you're lost, just let me know you're completely lost. Haley, correct. Cassidy, try again. Gemma, try it again. Let's take a couple more answers or a couple more responses. And let's see. Cassidy, try it again. Tiara, wrong. Try it again. All right. So let's see what this question is trying to see, right? If we look at the diagram, right? EH, from E to H, and they said it somewhere here, right? Look at it, said it. EH is 1U, right? So, but the examiner is asking us for HF. Remember, HF starts, H starts here, and F finishes here. So this is HF, this portion of the line. Now you realize this is one straight line, right? Look at this. They gave us a clue. They said EF is equal to 3EH. So let's use that clue. EF, if we want to find it, apparently we have to take EH, and there's a secret multiply here, and we have to multiply it by 3. What's the value of EH again? EH is just simply the letter common U. So you know what they're trying to say? The value of EF from here all the way to F, from E to F, the whole thing is 3U. But the examiner for part A does not want the whole thing. If the whole distance is 3U and this distance from here to here is only 1U, how much is the balance? How much is from H to F? The whole thing is 3U and the first portion is 1U. How much U again do we need? Right, and everybody's sending the correct answer now. From H to F, right, is Let me change the color here. From H to F is, let me write it there, blue, is 2u, right? So keep that in mind. That's going to be update your diagram. From H to F is 2u, and the whole thing is 3u, and this portion is 1u. And it makes sense, right? U plus 2u is 3u. So we just answered the first part. HF is 2u. Let's get started on part B. Part B, MF. MF is here. M, and we want to go all the way to F. Let's work out a plan first of all. How can we walk from M to F? To walk from M to F, it have plenty ways. We could go from M to G, G to F. We could go from M to G, G to H, H to F, or we can go from M to E and then walk from E to F. That's the plan I am going to choose. Anyone will give you the correct answer. So take down the plan for part B. To walk from M to F, we're going to walk from M to E. And once we reach E, then you put an addition sign. Then we walk from E to F. Right, so take down the plan there. And let's see what happens. Now they gave us a hint here. Look at this hint here. M is the midpoint of OE. So then what I'm already trying to say is that M is in the middle of OE. He is in the middle of this line. If from here is O to M is positive 1V, how much is from M to E? Anybody want to take a guess? If M is the middle, right? Cassidy, correct, right? Haley, correct. And it will also be V. It's like this. If you have a race, and if I tell you you run in a race, right? You have O, M, and E, right? And I tell you, you run from O to M, and I tell you from O to M is 5 kilometers. And I tell you, hey, you finished your race, you only at the midpoint. Won't you have a next 5 kilometers to run? The point is, if M is the midpoint, this value and this value has to be the same. So that means M to E is also V, because if from here to here is V, then you have to run a next V to complete the race, right? Let's change this here. All right, and people are sending the correct answers now, right? So let's finish this question. MF, M to E is V, and E to F, what we have it on the board here, is 3U. That's the final answer. We can't do anything more. V plus 3U. All right. Everyone should be able to get out OH now. The easiest way to go from O to H, right, is to go from O to E and then E to H. And that's the easiest way, right? And Stefan, I think you have it correct there. Rian, correct. A few other people got it correct, right? Tiana, Joseph, correct. Amber, correct. Right? So from O to E, that's 2V, right? A V and a next V. So V plus V is 2V. And well, EH, we have it on the board there, is U, right? Right, I should probably, so from O to H is 2V plus U. I should update my diagram, right? And from M to F, I should put in my values, V plus 3U. Update your diagrams, huh? From M to F, remember we have that value. And from O to H, we have the value. All right. This is where it gets complicated now, right? This is not the complicated part. We only did the easy part. Read part 2. All right, so part 2, they gave you the answer to work towards. So you have to try to find OG, and if you do everything correct, you are supposed to end up with this answer. I guess I like questions like this, well, where they give you the answer, and you just have to provide the working to show how you arrive at the answer. Let's begin. OG. What's the easiest way to go from O to G? Well, to me, to go from O to G, I think the easiest way is to go from O to M and then M to G. Let's stick with the simplest plan, right? And people are saying, they said it before me, so that's good. OG is from O to M and then M to G, right? So put down the plan. Do we have the value for OM? Yes, I think we have the value for OM. It's clear on the board here. O to M is just V. Now we got to be careful here now. On the board here, well, I say board, but it's already a screen. Do we have the value from M to G? Yes or no? From just looking at my diagram. Do we have the value from M to G? And it's right. And it's no. We have the value from M all the way to F, which is V plus 3U. This V plus 3U is for the whole line, but we just need up to G. So how do we find MG? Well, they gave us a hint in the question. Look upstairs here. MF is equal to 5mg. Let's write this back here. So let me write it back here. The examiner said MF is equal to 5mg. There's a secret multiply here. So that means the examiner is really saying MF is equal to 5 multiplied by mg, which means we could transpose to find mg. Here's a multiply. Throw across the multiply, we get what? A divide. So that means if we take mf and divide it by 5, we will get what? Mg. Luckily for us, don't we have mf? This is mf here, right? So that means mg is mf, which is v plus 3u, and we just have to divide the whole thing by 5. So now we have an expression for mg. Take down over there, right? To be honest, questions, I really hope you all don't get a hard question like this in the exam, right? It is possible you could get it, but very unlikely, right? But let's just still practice with it in case you are the unlucky batch in 2022 to get something this difficult. Right now, I'm going to keep working in fractions, right? And I'm going to convert anything to decimals. Why? Because our answer that we are supposed to get is in fractions. So I suggest we keep working in fractions to match our answer. All right. So remember, things like V is the same thing as 1V, and this is 1V, and this is 1V. The examiner is just not putting it in. Right? So I just need to erase this little section here, right? I want you all to try to simplify this now for me. Simplify this area here for me. Take 1V and add it to this expression. All right, so answers are coming up. So you have 1V here plus, and this 5 means both items get divided by 5 at the same time, because it has one huge division sign. So this is really 1/5 V plus 3/5 U. Both of them get divided by 5. Stefan, stick with what? The fractions. Remember, we said we're sticking with the fractions because the answer we are supposed to get has fractions. So we add up all the V's, so we can add up these two V's. Now, if you have 1V and you add 1/5 V, that is just 1 and 1/5 V. Because if you have one cake and somebody give you 1/5 of a cake, that is one cake and 1/5. And well, the U has no friends here, right? So let's convert everything to improper fractions. I don't like this 1 and 1/5. 1 by 5 is 5 plus 1 is 6. So we get 6/5 V, which is the same thing as 1 and 1/5, and 3/5 U. If you notice, our answer does not look like this. Well, yet anyway. But I guarantee you that this will eventually end up looking like this. Let's factorize. Now, just in case you all cannot remember how to factorize, right? We did it last term. Let me just slide here over here. Remember, if you have something like 2x plus 6y, and I ask you to factorize this, the most obvious thing to pull out here is 2. But what do we mean by pull out a number? If I decide to pull out 2, that means I am secretly visiting everybody here and dividing them by the number I am pulling out, which happens to be 2. 2 divided by 2 is x. 6 divided by 2 is 3. But that's easy. You probably didn't need to do that. You're going to do that in your head. But we're going to apply the same concept here. What we are going to do, we are going to factorize out 3/5. Sounds strange, right? Because you're not accustomed pulling out fractions. Usually when you factorize, you pull out a whole number. So that means we are secretly visiting everybody here and dividing here by 3/5 and dividing here by 3/5. Divide this on your calculator and divide this on your calculator. And tell me if you get 2V plus U. Well, in case you don't know how to type in fractions, right? If you want to type in 6/5, 6, you press the ABC button, ABC 5, that's how you write 6/5, divided by 3/5, 3 ABC 5. And you get 2, right? When you divide these two things, you get in 2V, and well, 3/5 divided by 3/5 will cancel out to leave you with the U. And ta-da, we got the same thing on the board. Well, sorry, in the past paper itself. Confirm with me when you physically see it on your calculator, just to assume that, hey, I can type in that when exam time comes. Do it now, get the practice of it. Right, Mara, you got it, great, Vishala got it, Jared, right, Ariana, Niranjan, Stefan, good. All right, so a lot of people are getting it. All right, so when you finish, give part 3 a read. Oh God, and part 3 is going to take us a little while. Once you can use your fractions button on the calculator, it will save you a lot of time in your exam. Part 3 a read there. 1, 2. What's another word for straight line in vectors? If 3 points form a straight line, what's another fancy word they can use instead of saying, hey, the 3 points form a straight line? Ah, everybody, people are remembering, right? Right? Collinear, right? That's the word, collinear. Someone asks, how can we use vectors in real life? Vectors is used for almost everything that has a position or a direction, including satellites around the Earth. Like if you're launching a satellite around to orbit the Earth or to launch a satellite to visit the different planets, you plot and you plan everything using vectors, right? Also, ships and aeroplanes navigate under the concept of vectors. So I hope that answers the question, Amir. All right. So if you want to prove 3 points are collinear, right? I'm taking you back to, I think, we did vectors in September going, so I'm going to take you way back. Whenever they want to prove 3 points are collinear, in this case is O, G, and H, you put down the 3 points, O, G, and H, just like how the examiner gave it to you. What you need to do is circle the first 2 letters, OG. And what you have to do is attempt to find that vector, OG. Luckily for us, don't we already have OG? OG is how much? 3/5 2V plus U. So I guess the examiner was kind of being nice to us. Part 2 is going to help us with part 3. Then after we find OG, we have to find what now? The next 2, the 2 last letters, which is what? G and H. So we have to find GH now. So I want everyone to attempt to find GH. GH is this vector here. I'll put it in pink. Right? From G all the way to H. So get working on that. Ask yourself, how can you walk from G to H? Right? There are plenty ways. You could go from G to F and then what? F to what? H, or you could go from G to M, M to E, E to H. Now let's agree on a method. Anyone will give us the same answer. How about we go from G to F and then F to H? That should be easier, right? G to F and F to H. Now be careful. Huh? This V plus 3U is the entire vector. Remember, MG was 1/5 of the line. You all remember that? from M to G, was 1/5 of the line because it was divided by 5. So if this part of the line is 1/5, then this part of the line is how much? How much you think is the remainder of the line? If the first part is 1/5, right, but then you're right, 4/5. Okay, so that should be a little hint there. I'll pause it there. It'll take a little while to work out that and simplify it and all that. All right, so we have to use factorization at the end of the day to get them to look the same. I propose that we factorize out 2/5. So we're going to pull out 2/5 from both of them. Now, if we are pulling out 2/5, that means we are secretly visiting him. Yeah, it have more than one Rian in the class. Sorry, I now realize. We are dividing both of them by 2/5. So divide him by 2/5 and divide him by 2/5. And tell me if the brackets end up looking the same. The number outside could be different, but the items in the brackets have to end up looking the same. So just confirm if they end up looking the same, please. All right. Yeah, Adara, if you take the 4/5 and divide it by 2/5, you divided that on the calculator. And when you take 2/5 and divide it by next 2/5, the 2/5 will cancel out. So you can try it on the calculator, Adara. 4/5 divided by 2/5, I guarantee you will give you 2. And well, these two fractions will cancel out each other because they are the same. Inside the brackets end up looking the same. Hence, they are collinear. And finally finished that question, right? And we got another 15 marks there in the exam. Oh, well, so okay, someone asked why we are pulling out 2/5. Okay, it's a kind of random, it's a trial and error because we're trying to pull out a number, right? That will end up making the brackets look the same. So remember in the first one, right? We had pulled out the number touching you. So I just, a little bit of trial and error. I say, well, 2/5 touching you. If I pull out the 2/5, well, then it will have nothing touching the you. So you could have either pull out 4/5 or you could have pulled out 2/5 in trial and error. And then what? See which one would what? Give you the brackets. Well, which one would make the brackets, look the same? I don't know if that answers the question, Adara, because I was trying to make the brackets look the same. So I had to like come up with a number to pull out. Right, so hence they look the same now, right? So hence prove that they are the same. So we just proved that they are collinear, right? Well, not all the time in custody. Sometimes you have to pull out the more scary number. Sometimes. All right. So to finish the question, once you get them to look the same in the brackets I'm talking about, you have to write a sentence now. Hence, OGH are collinear. Or you could say OHG form a straight line. Any one of them will give you the full marks, but you have to write the sentence at the end and use the word hence, right? Yeah, only, right, Amir, only the brackets need to look the same inside the brackets. The numbers outside can be different. In most of the cases, they will be different, right? All right. So I know we didn't get a break today, but I want to discuss the homework, right? And it's going to take us a little while to discuss the homework. So I need for everyone to make sure that when we discussing the homework, you're just not taking it down mentally. I need you to physically write it down. Because when it comes to making sure that everyone in the class moves at the same pace, everyone has to do the homework. Otherwise, it's going to make the class trail. Okay. All right. So the main topic that we're going to be starting in February, right? Because we still have the rest of this past paper to do, right? But in February, we are going to be starting with trigonometry. Well, it's called it trigs and bearings. That's the first major topic that we are going to do. So I'm going to show you exactly which videos you need to look at and make notes. Right, so let's go over here. Let's give me a few seconds again. So you all know the school website by now, right? The iLoveLessons. If you all lost the website address, I'm sending it back on the chat here. So if anybody lost it, they can always get. I'm sending it like 3 times. And the password is still the same to access the website. It's Ocean, OCEAN, but everyone can spell Ocean, right? All common letters. So you're going into the maths classroom, right? When you go into the maths classroom, it's 2 sets of videos I needed to look at, right? Everyone look at lesson 10. Make a note. Lesson 10 actually named trigonometry. So make a note, lesson 10. That's the first thing. Now, when you go into lesson 10, when you click on it, you have to do from videos 31 to 39. I know some of you all already did these videos. If you already did these videos, at least just review the notes you made. So when you come to class in February, it's not rusty in your head. All right. For those who never did videos 31 to 39, you have a lot of work ahead of you for the whole of January. Every week, do a couple of the videos, right? Don't wait till last minute to do all of them. The next set of videos you have to prepare for February is lesson 20. That's bearings. Bearings and trigonometry go hand in hand. One question will have trigonometry and bearings mixed up in it. All right? Everyone good so far? That you're doing lesson 10 and lesson 20 in the math classroom. Make a note, and how I'm going to be doing it, right? I am not going to wait till February to test you on if you did all the videos. Next week, I'm going to ask you, hey, if you started it, and I'm going to ask you little questions on like the beginners videos and to make sure that you're actually doing it on your end, right? Bearings, when you click on lesson 20, inside bearings it's only one video. Bearings is only one video. When you click on lesson 20, it's just one video, right? You don't have to do the worksheets. You just have to watch the videos and make notes and make sure you understand the theory. If you want to do the worksheets, feel free. All right, but most likely you're not going to have time to do the worksheets. Just make sure you understand the videos and you make your notes. At least that for me. The other thing is this, right? The recorded classes, right? I'm going to make a better attempt at uploading the recorded classes. So in recorded classes, I organize it a little bit better now. Monday, Tuesday. So, but the recording will only last 3 days, okay? So you don't have to WhatsApp me and ask me for the link. Like if you miss class on Tuesday, just go to the recorded classes and you'll see the link for class. I know last term I didn't do a good job at uploading the videos and being efficient at it, but I organized myself. The videos will be uploaded after class. I'm 100% sure. The other thing that how much of you all are kind of rusty on the Form 1 to Form 3 topics, like things like areas, fractions, like little things like that now? How much of you all are a little bit rusty on those topics? You will get those things for CX here, right? Right. So I have a plan. A lot of people are saying yes. And it's pretty normal to get rusty on those Form 1 to Form 3 subject topics, okay? With triangles and circles and all of those things. So I have a plan in place. Now listen to it properly. My Saturday maths class, right, is review all of those topics, things like areas, fractions, and things. We just do real revision on those old time topics. I am not asking you to come this Saturday class. In fact, it doesn't have space in the class, right? But the Saturday class, no, you're not coming this Saturday class, right? You're not coming this Saturday class. What I'm saying is the Saturday class will be recorded and the link will be placed here. But remember, you only have 3 days to watch it, right? It's mandatory for everyone in class to watch the Saturday recordings and make your notes. It's mandatory because what's going to happen, the first 4 or 5 questions in CXE is going to be based on that theory, the Form 1 to Form 3. I'm not lying. The first 4 to 5 questions is Form 1 to Form 3 work. That's a big chunk of your exam. So everyone understands that every week you have to watch the Saturday maths recording and make your notes. I will be following up with all students with it. And the minute I realize that, hey, you're not doing the homework, your parents getting a call. The adults, I can't do anything about that. But once you're in school and your parents paying your fees and you're not doing the homework, you're getting a call immediately and you're going to end up doing the homework in any case. Once you understand what the homework is, you are free to leave. The only people who cannot leave is the new people in class. Like if this is your first class ever with me in life, stay back, okay? The videos only last, okay, Tiara, the instructions at the top here. The recordings only last 3 days. So if your class is today at Tuesday, by Friday, it's gone forever. The Saturday class, right? If the class is on, the recording is on Saturday, 3 days after, the recording will be removed, okay? All right, so take care, guys. And remember, the new people stay back, okay?